Okay, redox chemistry. This is great because now this is new stuff that you haven't covered in this site, which can do a bit of a relief to finally be looking at something new. Now, as it says in the booklet, redox chemistry is actually really, really common. Lots and lots of reactions involve oxidation and reduction. And that's what this is. It's a manufactured word, if you like. So this red part comes from reduction, and the ox part comes from oxidation. And if you looked in the unit outline, you would see that this all sits under a heading of electrochemistry. And the reason why it's called electrochemistry is because what we're interested in is the transfer of electrons. And that's what happens in electrochemistry and in redox reactions. We've looked at a lot of reactions in phys-sci, or the ones that we looked at in quite a lot of detail aren't redox reactions, and that's precipitation reactions. And maybe in a few minutes you'll be able to explain to me why they aren't. So let's have a little bit of a think about what is a redox reaction? Or how can I think about a redox reaction? And a reaction that you've done in phys-sci, but we never really talked about in any detail, were metal displacement reactions. So we did some of them, but we didn't talk about what kind of reactions were occurring. And if I look at our example on page 4, we're talking about displacing copper ions using zinc. So what happens with copper ions and zinc if I combine them together in a test tube or a beaker? And I'm going to put them in a beaker because it's easier for me to draw. Here is my beaker. There's my copper solution. And I've got a piece of zinc in there. Now, a spontaneous reaction will occur. What does spontaneous mean in this context? Anyone got an idea of what's going to happen with it? You say it's a spontaneous reaction.
It just happens out of nowhere.
Yeah, it just happens by itself. We don't have to do anything to induce the reaction. It just happens by itself. And the reaction that's going to happen by itself is that zinc will dissolve. Okay, so the zinc that is solid here is we're going to end up with zinc ions in solution. And the other thing that will happen is the copper ions are going to become solid and make a deposit. And you might remember that we did this right back in that very first prac where we had this reddish kind of sludgy thing forming. That was a redox reaction. And what I'm missing at the moment are these electrons. And what I can do is include them in the equation. So if I have some zinc metal forming zinc ions that have a 2+ charge, then I'm also releasing 2 electrons at the same time. There? And these must always work together. Because if I'm releasing electrons, they have to go somewhere. They're never just loose in solution. Okay? It's a donation and an acceptance. So if I've gone from this 2+ ion of copper to solid copper that has no charge, then hopefully you can see that those 2 electrons have been taken by the copper ion to then form solid copper. Now, we have some definitions. Oxidation. Back when the term was formulated, we thought it was thought of only in terms of adding oxygen. But we have a much broader definition of oxidation now. Oxidation is loss of electrons. And so, if oxidation is loss of electrons, this is oxidation. Because the zinc has lost electrons and becomes zinc ions. And reduction is gain of electrons. And so the copper ions here have been reduced. They happen in pairs because of this, it's electron transfer. It has to go from one substance to the other in the one step. And so we can then end up with joining these together. When we join them together, we have to make sure that we have the same number of electrons on either side of the arrow, which we do have in this case. And so I can write a total equation, a redox equation, setting zinc solid plus copper ions, giving me zinc ions and copper. Can you see that all I've done is join those 2 equations together? And I've had to make sure that the electrons balance. So that's what's happened in the first example. Now I want to just have a bit more of a look at oxidation. Because if you can get oxidation in your head and you know that reduction is the other way, then it doesn't matter what the reaction is, you won't get lost because you'll be able to find the oxidation reaction. So you ready for me to rub all this out? You can always take a photo or watch a video if you haven't quite got to. Okay, so if in looking at oxidation, a reaction that we've done a couple of times, magnesium metal, and we burn it, yeah? And so it reacts with the oxygen in the atmosphere. What does it produce?
Magnesium oxide.
Magnesium oxide. My equation's not balanced. What do I need to do?
2 magnesium metals and 2 magnesium oxides.
Okay. Now, with magnesium, where is it on the periodic table?
That way. Then there. Oh.
Yeah, look, we're all pretty much correct.
Yeah. That way.
Group 2. What do you remember from 5th Sci about group 2 metals?
Alkaline.
Sorry?
Alkaline.
Alkaline, earth metals. What kind of ions do they form?
Metallic.
2 plus. Okay? The only ions group 2 metals can form are 2 plus ions. They're in group 2, they've got 2 valence electrons. They react by donating those 2 electrons. Same here. In this case, if I think about what's happening with my magnesium, it's forming a 2 plus ion. What's the charge on the oxide ion? 2 minus. That's why they're in a 1-to-1 ratio in the ionic structure. Yeah? So if I just look at magnesium from a redox perspective, I started out with a solid magnesium and I've produced magnesium ions. They're in the solid, but there's still ions. So if it has a 2 plus charge, then it has donated 2 electrons. And this is oxidation then. And the reason why I like this one is because we are actually adding oxygen. That is oxidation. Oxidation would mean adding oxygen. And in this example, we're adding oxygen to the magnesium to form magnesium oxide. So what's happening with the oxygen? Well, firstly, I'm starting out with oxygen gas. Yeah, so it's O2. So I do need to put a 2 out the front here so that I'm balanced. And now if I look at my charge, I've got a 4 negative charge on this side because I've got 2 oxide ions that each have a 2 negative charge. So to balance this, I need 4 electrons. Okay, so now my charges are balanced. This is obviously reduction, because reduction is gain of electrons. But if I wanted to write out a full redox equation, I need to balance the electrons. And at the moment, I've got 4 electrons in my reduction half equation and 2 electrons in my oxidation half equation. So what do you think I'd do? Multiply everything by 2. Okay, so, and how I would normally write that is I put big brackets around the whole half equation and just write times 2. Have to remember to do that to everything in the bracket though. That means that my electrons will cancel out. I'm going to need 2 Mg plus O2, and I've got 2 Mgs and oxygens. And that brings me back to my original equation, which was balanced, so it makes sense. Okay, so oxidation is loss of electrons, reduction is gain. They have to happen at the same time. If you get confused, think about what's happening with magnesium when it reacts with oxygen, and that the electrons are a product, if you like. And so we often call this a half equation. This would be the oxidation half equation. This is the reduction half equation. And this is a full redox equation. Is everybody sort of happy with where we are at the moment? Because I'm going to say something that's totally going to confuse you.
No one likes to.
Just be alert for confusion. Okay.
That doesn't confuse me.
Common knowledge, really.
So is everyone happy that the magnesium is oxidized?
Yeah.
It's oxidized because it's lost electrons. I can also call it the reducing agent.
Oh.
That's a stupid command.
Because it causes the oxygen to be reduced by itself being oxidized. It's causing reduction. It's also, we can also call it the reducer. And the same with the oxygen is itself reduced, but it is the oxidizing agent or oxidizer because it is taking the electrons from the magnesium and causing it to be reduced. So the reactant that is oxidized is the reducer, and the reactant that is reduced is the oxidizer. And at that point we will stop and you can have a look at questions on page 7.
So the magnesium is being oxidized to reduce the oxygen.
Yes.